right, well, unless you've been living under a rock, a lot of people heard of Wi-Fi 6E and probably heard 6 gigahertz was coming. It brings a lot to us. Personally, I was extremely excited because it makes everything Wi-Fi 6 better. First off, we've done a lot of studies, testing and looking at the question. It's, how does this perform in a multi-client environment? Can you do BSS coloring? Do you get the advantages of OFDMA? And a lot of people want to know this because the applications, which has been driving wireless, in my opinion, all along, the applications are getting more demanding and the expectation is getting more demanding. And basically, people don't connect any other way now. If you're connecting wired, you're definitely in the minority. And, we kind of knew this was coming. You can see the build of it over the years. If you listen to the press, you hear 5G everywhere. And yeah, 5G's coming, and I do believe that it's got a place. There's a lot of Wi-Fi already here, and it's just getting better. So if you take a look at it, 30% growth year over year, projected through 2023. And I can tell you, I used to not put a lot of faith in these reports until we were talking about by 2018, we'd have more wireless on the internet than wired. And then that actually happened in 2016. I look at these a little different now. But what's interesting is what's growing. To me, there's billions of devices coming, and the fastest growing segment of this market, and we think it's due to continue that way, is actually machine to machine, and that's a serious impact on a lot of people's Wi-Fi's. If you take a look at the share of that and how everything else is shrinking, that's because it's giving share up to machine connections. And if you take a look at what's driving machine connections now, connected home is the largest, followed up by connected automobile as far as growth goes. But there's a lot of investment going on in connectivity, and there's a demand for this, almost assuming that it's got a Wi-Fi connection. Very few of these devices actually come out with cellular chips in them. So I think this is destined to stay Wi-Fi for a little bit, at least in the consumer market and a lot in the professional market. We're seeing a great deal of investment going into retail, and manufacturing and supply chains are actually growing. So what did we get with Wi-Fi 6E? Well, we got 1,200 megahertz of spectrum. To put that into perspective, that's double, actually more than double, of all the spectrum we've been granted in 3 separate grants thus far. Which says something about where the FCC considers Wi-Fi today, which actually started as an experiment some 35 years ago, with a lot of trepidation about what we would do for interference. But we got incredible bandwidth, 2 gigabit speeds easily now. OFDMA scheduled, reliable, scheduled. We can actually schedule and can segment the network by policy, quality of experience. It's a clean RF spectrum. It's 6 gigahertz of spectrum. And as far as low power goes, we're going to be indoors. It should be just us and all us, with, possibly some LTE, NR. But optimized delay, as low as 2 milliseconds, consistent, and we've seen that and tested it. It's actually predictable, which is not something I've ever seen in wireless, being on the Wi-Fi side of it. And then we can finally use those wider channels, right? So we've got improved location because of a wider channel as a benefit to that as well. And we won't have any slow devices because this is Wi-Fi 6 only. So it's as close to a greenfield as anybody here is ever going to see, which is good. Use cases, I'll dabble through these real quick, but what we see growing is healthcare. Particularly these days, there's a big growing investment in telemedicine. My own state, Maryland, in the U.S., had something on our books that prevented telemedicine or doing doctor's appointments via video, that got rushed through for emergency legislation here for some reason about 2 months ago. And we're now opened up to it. So there's investment and growing opportunities here. But all of this comes with bandwidth requirements. And right now, if you take a look at most consumer locations, you're not going to be doing the kind of bandwidth that you can take advantage of with Wi-Fi 6, but that's changing as well. Inside, a lot of telemedicine going on between facilities. We're seeing 28% growth there. We also see collaboration efforts. I heard a report, and I couldn't find it before we jumped on here, but one of the statistics that we heard, we got back from Comcast folks, Xfinity, that they saw a 228% increase in traffic driven through residential areas, and that was primarily video and audio streams, collaboration efforts. So cloud productivity is going to take a lot of that up as well. And then digital learning. Universities right now are taking a look. Higher ed is taking a hard look. More distance learning and VR, AR experience apps. I mean, these are going to drive some serious bandwidth. So just for getting back and taking a quick look at what we had a grand total of 583 megahertz, and we had a discontiguous 583 megahertz. So there's always been this perception that we are lacking. And I remember back to when somebody asked when we were going to get more spectrum, and everybody was hovered in 2.4 still, and we weren't even touching 5 gigahertz. And the only answer I could give them was probably when we use what we've got. Well, we definitely did that. The new Wi-Fi 6 gigahertz band is broken up into 4 unis. We don't get into the first channel until we get a decent guard band, but the difference here is absolutely staggering. I've got 59 20 megahertz channels across 1200 megahertz of spectrum and 29 40 megahertz. 80 megahertz is entirely possible. Now, one of the things that I've seen some people struggling over is we got brought in under what we call LPI, or low power indoor rules, right? And 5 dBm per megahertz is the power limits. We're very used to seeing channel power. The other way that we can go at this, and this hasn't been completely worked out yet because of the dependency on automatic frequency coordination, is standard power. And this gives you the outdoor option. But it requires a much stricter compliance. You're going to have 30 degrees above the horizon, max up tilt. The incumbent users in this band are fixed satellite stations, Earth satellite stations. So these are pretty important links. So we're going to have to make some work to coordinate that. Having said that, you get a lot more power in that band, and you can go outdoor with it. Clients all along going to be 6 dBs less than the AP's max, so I don't really see that as a problem. If you think 18 dB on an AP, drop it by 6, 12 dB is about the best client power we see today. And then under consideration is a very low power devices, but there's going to be much more on that later. So let's talk about what the guys doing standard power actually get. They get a couple of hunks of the band, but they're limited to those hunks of the band. They can't actually go in 6425 and 6525, and that actually breaks up the utility of that for wider channels. But that's the only negative or downside that I've seen so far with 6 gigahertz, and I'll show you why I think that. If you take a look at the power limits for the low power indoor, that 5 dBm per megahertz, that is a power spectral density limit. So what the FCC did was they gave us a limit for any given megahertz segment within the channel. And the proper way to look at that then for the channel power is to multiply that by the number of megahertz that you have in there. So breaking it out as the milliwatts, that gives us 18 dBm for a 20 megahertz channel, 21 for a 40, 24 for an 80, and 27 for a 160, which, by the way, is actually possible now, which is fairly exciting. The downside to using bonded channels, and one of the reasons that, I today even still recommend 40 megahertz in traditional Wi-Fi, is because a wider channel creates more noise, which means that we're going to lose signal to noise ratio every time you double a channel. Forget that it's difficult to fit many bonded channels in a lot of installations these days. The SNR hit alone really kind of takes you down. If you take a look at that, you lose 3 dB per doubling. So I've put 5 gigahertz Uni 1 and compared that to 6 gigahertz for each channel bandwidth. And what you can see clearly is the effective EIRP dropping towards 14 for 160 megahertz channel and 5 gigahertz today. But that's because we don't have the power offset. And that PSD power lets us continue to build power as the channel gets wider, which actually gives us, if you look at the effective EIRP for Unit 5, you're getting 18 at the first doubling, 21, and then 24. So we offset that 3 dB loss. So we actually encourage then the use of wider channels, which is good. So I did some modeling. I thought about this a little bit. I know it's rare when that happens, but it happens, and here we are. 5 gigahertz Uni 2 on the left, 6 gigahertz on the right. So if I take a Uni 2 AP that's operating at 23 dBm EIRP, and I take 80 megahertz of spectrum, I'm going to lose 6 for the SNR. I put next to that what I've modeled as a 6 gigahertz, and I took 24 dBm as the maximum EIRP, which at 80 megahertz comes out. And we're going to get path loss in 6 gigahertz, which is a little higher than 5 gigahertz, but it amounts to about 1. I've seen 1.2 dB if I match it frequency for frequency across the range. What you end up with is 41 dB of SNR. And that's for a pretty good chunk of area. And that's actually really good because that's where we have MCS 11. So a little while back, we did some testing, I think it was February this year, of very dense environments. We kept getting people tell us that they're putting in 700 square foot cells, 600 square foot cells. And, I'm thinking to myself, that's pretty dangerous, but it's doable if you got a lot of stuff in between it. But all things created equal, out in Richfield, Ohio, where some of you might know Fred Niehaus and the boys that make our APs all live, we've got a facility out there that's exactly 15,000 square feet, and it makes it real easy to put 15 APs in and do 1,000 square feet. So we went in first because of the questions we had at 80 megahertz using FCC channels, which is arguably the highest number in the world at this point. And the way it breaks down is this. 5 gigahertz interfaces, we've got 15 of them at 80 megahertz. We've got 6 80 megahertz channel in FCC. So that gives us a reuse rate of 2.5 times, meaning every 2.5 APs, I'm going to have to redo a channel. And that's actually what we got. We got 10 of the 15 APs in that space, spaced by 1,000 square feet. 10 of the 15 APs wound up on duplicate channels with another AP in there, which I didn't include the testing here. We went ahead and tested just so there wasn't any questions on it. We did that with 40 megahertz. And the real sacrifice in Wi-Fi 6 was the latency, which went completely through the roof when those two cells had to work around each other. So 80 megahertz and 1,000 square feet is not even possible right now with 1,000 square foot cells. However, you replace that with a 6 gigahertz channel plan, and the math changes completely, right? And at 1,000 square foot cells using 80 megahertz channels, I've got 5 APs that are well outside the interference range of the APs that are already existing. So only having to double up a channel on one AP, and that's at 80 megahertz, that's what this does for us. It's amazing. Why do we need this much bandwidth? Well, we did some testing also using 40 megahertz as the guideline, because realistically in 5 gigahertz, that's probably what we're going to be able to support if we're careful. And we didn't have any 8K test clients or test scripts yet, but we did use a video, Blu-ray video download, and we made it 80 megahertz as our bottom end. There's some arguability. We're going to see it a lot less by the time we get into 8K video with different codecs, but 80 megabytes per second is a bottom limit. Seemed like a fair limit. We ended up getting 760 megabits per second. This was over-the-air testing in a wide-open environment. One-way latency below 50 milliseconds. So Wi-Fi 6 definitely works. And that's a sustainable, I think, 8K video clients. 8 of them on a 40 megahertz cell seem like pretty sustainable stuff. Why is this appropriate? Well, if I take a look at just building 22, and this is back at the factory or San Jose, the density of the seating, right? If I took a look at 8K video clients, I'm looking at 3,000 square foot where I've outlined, and in those seats, I've got 42 seats, 14 users per AP. If only 8 of them can get 8K video and that's one way, I'm going to be in trouble pretty quickly when I start doing two-way or I start doing VR, AR apps. So the density definitely has to go up if we're going to support some of these applications in the future. The coverage is about the same, but we're going to need frequency to separate it. The other alternative is we start getting into antennas. So the way I read this right now, if we take a look at 5 gigahertz in dash B for reference, we will recommend 40 megahertz all day long, anywhere between 15 and 2,500 square feet. You can do it in 1,000 square feet, depending on your infrastructure. If you've got bomb shelter walls between your rooms, it's easy. If you've got paper thin and wide open office area, it gets a little more challenging. 80 megahertz, not even viable in 1,000 square foot, in my opinion. People would get in trouble with that. 160 megahertz, not really viable in any distance that has opening between them. So it's a real challenge to support. You bring in 6 gigahertz though, and 80 becomes the new 20, and 160 is actually realistic and probably doable in 40 megahertz in most environments. We spend a lot of time looking at the ramp because being a manufacturer, we need to have equipment ready and we need to have knowledge ready for when it actually takes hold in the marketplace. And if we take a look at previous ramps, Wi-Fi 6 is actually ramping faster than AC did. We expect that 6 gigahertz is probably going to enter the market. There's some cool use cases right up front, like indoor mesh that become possible, but probably starting to enter the market. It's going to be first half of next year when we start to see chipsets. So we've got a ramp period now between now and 2022 to start thinking about this, probably product delivery starting in 2021. We've got a ramp period here, and we've actually got a technology that competes and compares very, very well if you take a look at 5G and the promises and the use cases that they're making. So I think this is, all in all, an extremely good thing with very low downsides. Lastly, I just wanted to give a shout out to Mary Brown and the fine folks that do our lobbying and standards. Spent a great deal of time here in DC last summer working with the FCC. A lot of people got involved in this. A lot of other companies got involved in this, but it was a real effort that paid off very, very well. 35 years after the FCC started that experience and that experiment, we've committed to it very largely, in my opinion. And that's all I had today. Mark?
Awesome. Thanks, Jim. Yeah, good morning, afternoon, evening, I guess, wherever you are. First off, I want to say thanks to Ekahau and Tony for letting me wreck this train here on with all you guys. So here's my quick brief view of my agenda. So quick intro about me and Walmart, and then, you know, from a customer perspective, why does 6 gigahertz matter? What does it offer us, and are there any risks? So I'm Mark Edwards. I'm CWE number, don't ask. So I came from a wireless vendor probably about 15 years ago. Have been supporting designing Wi-Fi for 15 years. Worked for Symbol and AP100s way back in the day, if anybody knows what those things are. About 8 years ago, I got started on at Walmart, and, you know, back to the CWE thing, you know, I've taken some of those professional exams probably more times than I would like to admit. But anyway, I won't recover some of the stuff that Tony already talked about from a personal perspective. So I'll jump right into the wireless team itself. So, you know, we're about 25 team members strong. We support a mixed vendor environment. So all the typical vendors you're familiar with, we probably support them. You know, we manage and design for the stores, our clubs and distribution centers, obviously. But there's some venues that we do that you might not, you know, expect, like conferences and arenas for some of the events that we have and things like that, as well as even pop-up locations, pop-up stores, manufacturing facilities, and even a dairy processing plant, which, you know, those are always fun, by the way, with stainless steel walls. Some fun facts about, our environment. We have over 250,000 APs in the U.S. Stores and clubs alone. Over 2 million unique clients daily in that space. One other fun fact is we removed some old SSIDs a little while back, and I was doing some fun math on that to see what that worked out to be, and we removed roughly 10 million beacons a second out of the air whenever we made that change by consolidating those SSIDs, and that works out to like 36 billion beacons an hour that we remove from the environment. So all of you that are next to us in the environment, you're welcome. So why does 6 gigahertz matter? I think Jim covered a lot of these things about the spectrum, right? We're already out of spectrum where we can't take advantage of some of the things like 40 megahertz channels. And in my space, whenever, someone from the business or someone from one other team has some cool, fun thing that they want to go plug in or a shiny new toy, it's never they want to plug it in, right? It's always a wireless device. And those devices are even more demanding on the wireless infrastructure now than they have been in the past. With greater availability, it needs to be always on. I need more bandwidth because I'm streaming, live video or whatever the case may be. What we find is that the 2, 4, and 5 gigahertz bands quickly, isn't enough spectrum. So, excuse me. Some more use cases for it is we're obviously seeing an exponential growth in devices. As we in the retail space start looking for ways of doing business, new ways of doing business, there's a lot of IoT, robotics, and automation that are at the center of that story. And the idea is not to replace associates. The idea is to free up associates to do more meaningful work and get some of this repetitive task stuff out of their way. In addition to those client counts growing, kind of like I touched on earlier, the bandwidth requirements are also starting to grow. So, we have a lot more robotics in the stores and our clubs, including distribution centers, cameras as well. And then we even have robots with cameras, multiple cameras. And so they're streaming a lot of high quality images or video back to either something in the store or in the cloud. And that obviously requires more bandwidth. And the challenge in our retail space environment is it's a very open sales floor. If you walk into the store, you almost immediately have a line of sight to 10 different APs, right? So again, that co-channel contention is a problem, and that's what keeps us stuck at those 20 megahertz channels without maybe some significant cost increase, like using external antennas and trying to shrink those cells down really small. But the challenge there is the cost for that just doesn't really scale very well.
How many stores you got to install that in, Mark?
Exactly. And at the scale, cost matters, right? Especially in retail where we're operating on thin margins anyway. So, and non-Wi-Fi devices are starting to leverage 5 gigahertz too. So, we think that spectrum is clean for us, but it's really not. We're finding more and more devices that are starting to use 5 gigahertz for non-Wi-Fi deployments like cameras, home theater systems, and even LAA. So this is an example of a home theater system that we found at Sam's Club a couple of years ago. One of my good friends, GT, worked for a company that we were piloting one of their solutions, and he kept telling me that I had this interference on 5 gigahertz, and I was like, no way. That's not possible. There's no 5 gigahertz interference. So we went to the club and, took our trusty sidekick and turned off all of our 5 gigahertz radios in the store, and then, proceeded to try to hunt this thing down. And sure enough, we found that it was a display for a home theater wireless speaker system. And, interesting enough, obviously you can see the interference there on the screen, but it didn't stay on those channels. We had an RF device and actually injected some noise onto 36, and we saw the device move to 40, saw it move to 44. So it definitely wasn't staying put, and potential for interference in other areas as well. We also have a 5G pilot in one of our stores, and part of that pilot, they actually augmented some coverage with in-store LAA, LTE LAA. And so clearly you can see here that's a problem in the environment, and didn't really seem to matter if we had APs, operating or broadcasting at the same time. They were operating on those channels regardless. We could see it pretty strong. So again, just a case that we need more spectrum. How can 6 gigahertz help? I think I'm going probably too fast, but I'm nervous. It's my first time, so bear with me here. So more spectrum equals
a lot of good questions.
more spectrum equals more bandwidth, right? So more is always better. And as we all know, or at least us Wi-Fi guys know, that channels equals bandwidth. So the new channels give us some great opportunities there, and not to mention we're already at Wi-Fi 6, so Wi-Fi 6 is already better than 5G, right? Because it's one number higher. So increased channel sizes, again, to what Jim already alluded to, stole some of the thunder. Oops, went too fast. The ability to leverage some of those 40 megahertz channels. There's finally enough spectrum to leverage those 40 and even above without the worry about co-channel contention. And we'll need those greater channel sizes for like the robotics, AR, VR use cases that we have in our stores, and we're ready to consume that already. Greenfield deployments, again, kind of like we touched on earlier. This is the first time in Wi-Fi history since 802.11, 802.11b that we actually have some greenfield type deployments, right? So some legacy protocols, won't hold us back, and we won't be stuck with some backwards compatibility issues that we've had in the past. So I think there's probably some interesting mesh use cases for this as well. One of the things we definitely have to do is beat the competition. We're already seeing, again, with the 5 gigahertz interference, we're sure to see the same thing happen in the 6 gigahertz space as well. I assume as 5G becomes more prevalent and they look to expand in building solutions, just like they're using LTE, LAA, and 5 gigahertz, I would expect to see that happening in the 6 gigahertz space as well. So I think the faster we get there, the sooner we take our stake in the spectrum, the better we are off. So what could go wrong? Is it possible the new spectrum has a downside, right? So there's nothing to fear but fear itself, right? So there's definitely some old challenges that we've already seen in the past that are going to reintroduce themselves or just be compounded. And one of that is device support, right? So like any mainstream technology, we have to have some devices that come along and support it. So Apple and Samsung devices, once those things start becoming mainstream, then obviously we feel good about those adoptions of 6 gigahertz radios. Just like BLE and previous wireless technologies, until there's a mass adoption, we don't really get any benefit from it. Hanging up a bunch of 6 gigahertz APs doesn't do me any good if I don't have any 6 gigahertz clients. And some other concerns around devices is, like I've had some conversations with some of the chip vendors, and their statement is their chip already supports 6 gigahertz. They're going to use the same chip, and they're just going to apply some different filters in order to achieve the 6 gigahertz spectrum. The challenge with that, to me, I think, is we're going to see that's just too much scanning and probing for clients to make good roaming decisions in enterprise environment. At your house, it's probably fine. In some smaller offices, it's probably fine. But if you look at a real enterprise where you have a high density deployment, having that single radio now scan 1,800 megahertz worth of spectrum is probably going to present a lot of challenges without really forcing some technologies like 11K and V and some of those things. Which brings up WFA certifications. Will the old rules still apply? In the past, we've seen devices get certified by the Wi-Fi Alliance that, presented themselves as being 802.11an or AC compatible, which meant they had a 5 gigahertz radio in them, but they didn't support all the channels. And so we found ourselves on the wireless engineering side having to either design around those devices or tell the business or customer that, hey, you're going to have a poor performance because we have to reduce this, or just tell them, hey, that device, you can't use it, right? So that puts us in a spot when we have a certification process that's not validating the complete part of the spec that we expect from from an engineering side of the house. Last thing is design and survey. I think Jim touched on a lot of this too about designs and power levels and AP heights and things like that. And is there going to be a difference and it's good to see that there may not be a big difference in how we approach those things. But even on the other side of that, from a survey perspective and even a packet capture perspective, how many dongles do I have to carry? And thanks to Jerry for some of these pictures, but at some point I don't have enough USB ports and the USB power to power all these things to do an effective packet capture, right? And so I think that's going to present challenges from a support standpoint, for sure. And unless we have some other mechanism to get good quality packet captures where we're seeing everything that's happening in the air. Beyond that, from a survey perspective, sidekicks are great, but how many do I have to carry? At some point, I'm going to have too many sidekicks. I'm going to need a sidekick array in order to survey all these channels without walking at a, extreme snail's pace. So I think those present some challenges for sure, and some things that we need to think about as the technology starts to come along. That's pretty much it for me. Thanks again. I appreciate the time, and I appreciate everyone joining and listening to me ramble through my first presentation. And Walmart's a great place to work. Just a quick shout out there. And if you guys are ever looking for any opportunities, there's a link there. We're always looking for great talent in wireless infrastructure or wired infrastructure or software design. We're always looking for great talent. Thanks.
Awesome. That's fantastic, Mark.